welcome to our channel. Today we will discuss the topic rational functions. Here are our objectives for this lesson. First, represent real-life situations using rational functions. Second, distinguish rational functions, rational equations, and rational inequalities. Third, solve rational equations, inequalities, and solve problems involving rational equations and inequalities. Fourth, represent a rational function through its table of values, graphs, and equation, and solve problems involving rational functions. Let us recall the following definition of polynomial function p of degree n. A polynomial function p of degree n is a function that can be written in the form p sub x equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus down the line plus a1 x plus a naught, where a naught, a1, and so on, an are real numbers, where an is not equal to 0 and n is a positive integer. Let us note that each summand is a term of the polynomial function. The constants a naught, a sub 1, and so on, a sub n are the coefficients. The leading coefficient is a sub n, the leading term is a sub n x raised to n, and the constant term is a sub 0. Now let's take a look at the following example. The municipal government allotted 500,000 pesos to provide financial assistance to selected students in the town. The amount is to be equally divided among the students in the town. The problem is, write an equation representing the relationship of the allotted amount per student, represented by y, versus the total number of students, represented by x. We have the following solution. Since the amount 500,000 pesos is to be allocated to x students, then each student must have an amount of y equals 500,000 over x. For the next problem, we have fill up the table below with the different allotment amounts for different values for the number of students. Suppose we have 20 students. Substituting it to the equation, we have y equals 500,000 over 20, which is equal to 25,000. For 50 students, we have y equals 500,000 over 50 equals 10,000. For 100 students, we have 5,000 each. For 125 students, we have 4,000 each. And finally, for 200 students, we have 2,500 pesos each. Next, let us define what is rational expression. A rational expression is an expression that can be written as the ratio of two polynomials. Let us consider the following examples. First, we have x squared plus 3x minus 2 over the quantity x plus 4. Note that this is a rational expression because it is a ratio of two polynomials. The first polynomial is the x squared plus 3x minus 2, and the second is x plus 4. For our second example, we have 1 over 3x squared. So this is a rational expression because the numerator 1 is a polynomial of degree 0. For our third example, we have x squared plus 4x minus 3 over 2. This is a rational expression which is also a polynomial. Next example, we have the square root of the quantity x plus 1 over the quantity x cubed minus 1. Note that this is not a rational expression since the numerator is not a polynomial. Finally, we have 1 over x plus 2 over x minus 2. Note that this expression is equal to 1 over the quantity x plus 2 multiplied by the quantity x minus 2. So, it is a rational expression. Now let us discuss rational equations, inequalities, and functions. What is rational equation? A rational equation is an equation involving rational expressions. Let's look at the following example. 2 over x minus 3 over 2x equals 1 over 5. Note that each term is a rational expression, and we have equality. Hence, it is a rational equation. Next, let us define what is rational inequality. A rational inequality is an inequality involving rational expressions. Consider the example 5 over x minus 3 less than or equal to 2 over x. Note that each term is a rational expression, and since we have inequality, we have a rational inequality. And we have our last definition. What is rational function? A rational function is a function of the form f of x equals p of x over q of x, where p and q are polynomial functions and q is the non-zero function. The domain of f of x is all values of x where q of x is not equal to 0. Let us consider the following example. F of x equals x squared plus 2x plus 3 over x plus 1. Note that the numerator and the denominator are polynomial functions and the denominator is a non-zero function. Hence, f of x is a rational function. We have the following important notes. A rational equation or inequality can be solved for all x values that satisfy the equation or inequality. Whereas, we solve an equation or inequality, we do not solve functions. Rather, a function expresses a relationship between two variables and can be represented by a table of values or a graph. Now let us discuss the procedures for solving rational equations. To solve the rational equations, first we have to eliminate denominators by multiplying each term of the equation by the last common denominator. Next, note that eliminating denominators may introduce extraneous solution. Hence, we have to check the solution of the transform equation with the original equation. We have the following example. Solve for x. 2 over x minus 3 over 2x equals 1 over 5. The LCD of all denominators is 10x. Hence, multiplying 10x in both sides, we have 20 minus 15 equals 2x, which implies 5 equals 2x. Therefore, x equals 5 over 2. Now, let us discuss the procedure for solving rational inequalities. To solve rational inequalities, first, we use addition or subtraction to rewrite the inequality as a single fraction on one side of the inequality symbol and 0 on the another side. Second, Determine over what intervals the fraction takes on positive and negative values. Consider the following example. Solve for inequality 2x over x plus 1 is greater than or equal to 1. First, we have to rewrite the inequality as a single fraction on one side and 0 on the other side. Subtracting negative 1 on both sides, we have 2x over x plus 1 minus 1 is greater than or equal to 0. Since we have x plus 1 as LCD, we have 2x minus x plus 1 over x plus 1 is greater than or equal to 0. Hence, x minus 1 over x plus 1 is greater than or equal to 0. Next step, we have the value x equals 1 is included in the solution since it makes the fraction equal to 0, while x equals negative 1 makes the fraction undefined. Mark this on a number line. Use a shaded circle for x equals 1, which is the solution, and a shaded circle for x equals negative 1, which is not a solution. For item C, choose convenient test points in the interval determined by negative 1 and 1 to determine the sign of x minus 1 over x plus 1 in these intervals. Construct a table of signs as shown below. Finally, we have step D. Since we are looking for the intervals where the function is positive or 0, we determine the solution intervals to be x less than negative 1 and x is greater than or equal to 1. So we plot these intervals on the number line. The solution set is the set of x that belongs to the real numbers such that x is less than negative 1 or x is greater than or equal to 1. It can also be written as from negative infinity to negative 1, open parenthesis, union, close parenthesis, 1 to positive infinity. For our last discussion, we have representation of rational functions. Consider the following example. Average speed or velocity can be computed by the formula x equals d over t. Consider a 100-meter track used for foot races. The speed of a runner can be computed by taking the time it will take him to run the track and applying it to the formula s equals 100 over t, since the distance is fixed at 100 meters. First problem, represent the speed of a runner as a function of the time it takes to run 100 meters in the track. We have the following solution. Let x represent the time it takes the runner to run 100 meters. Then the speed can be represented as s of x equals 100 over x. For the second problem, construct a table of values for the speed of a runner against different run times. For the solution, let x be the run time and s of x be the speed of the runner in meters per second, where s of x equals 100 over x. If x equals 5, then our x of x is 20. If x equals 15, then our s of x is 6.6. And if x is 25, then our s of x is 4. For the last problem, plot the points in the table of values on a Cartesian plane. After After plotting the points, we obtain the following graph. And that ends our discussion for rational functions.